Today we will be going through what similarity is. So similar figures are the exact same shape but can have a different size. Okay, so just as long as we have two figures that are the exact same shape, so for example, rectangle, rectangle, triangle, triangle, trapezium, trapezium, then that satisfies similarity, but they can be different sizes. So we might have a little rectangle, but then a bigger one as well. Because they're both rectangles, we can say that they are similar figures. Unknown side lengths and angles can be found using a scale factor. So all the questions I'll be going through today will show how we actually calculate a scale factor. Now it has its own formula. So the scale factor equals the image length divided by the original length. Now, if the image is bigger than the original, the scale factor will be greater than 1. So for example, if we had two triangles and the original image, the original triangle looked like this, and then the image of the triangle looked like this one here, you can see that the image is bigger than the original triangle. So you would expect a scale factor of these triangles to be greater than 1 because what we've ended up with is bigger than what we started with. It's as if you're zooming into something on a Word document, for example. If you zoom in on the page gets bigger, 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 bigger. All right, similar kind of thing here. On the other hand, if the image is less than the original, the scale factor will be less than 1. So this time I've got two triangles again. The original is a larger triangle compared to the image, so as if we're zooming out on something. And because what we've ended up with is smaller than what we began with, the scale factor will be less than 1 because the size of the triangles have decreased. Okay, so we'll go through this with 4 different examples. Question number 1. Determine if the triangles are similar. Now, for us to figure out if these are similar or not, we must calculate a scale factor. For the scale factor to work properly, we need to make sure that each of the sides in both of the triangles align with one another. So you need to make sure that the triangles are facing the exact same way if you want things to be easier for you, in order to match up lengths that belong with each other. So it'll only work if whatever length in this triangle, for example, matches up with this length in this triangle here. If you tried to put this 5 centimeters, for example, with this 4 centimeters over here when they're different sides of the triangles, then it won't work. So you need to make sure you match up all the correct sides with one another. Now, to do that, I'll be using different colors to make it easier. So I'm going to look for my largest side here. Well, my largest side length is the 8 centimeters over here. So I'm just going to underline that in green. Now I'm going to try and find the largest side length in this triangle here, which happens to be the 7. So I'll do that in green too. Then I'm going to find the smallest side length in this triangle, which is the 4. And the smallest in this triangle is also 4. Then we have 2 sides left over, so that's easy. They obviously match up with one another. Okay, and I'm going to label these triangles as original and image. Now, whatever's on the left-hand side, you can just assume is the original shape, and whatever's on the right-hand side is the image. So it goes original, image. So I'll go original, image. Okay, So the scale factor and I'll just write image over original. So remember this, that's this formula that I introduced to you here. You can pause and write this down in your books here if you want. For these two triangles to be similar, you need to find the scale factor of every single side length of the triangles, and they all need to equal the same number when you put them into this formula. Okay, so we'll start with green. It's original divided by, image divided by original. So the image of green is 7 divided by the original of green, which is 8. And then let's do the same for pink. Image, so this side over here for pink, which is 4, divided by original, which is this one over here for pink, which is also 4. And then we've got blue. So image, blue, which is 5. And then original blue, which is 6. So what we need to do now is we need to find out answers for all of these, and we need to make sure that the answer for all of these calculations, which is the scale factor, all equal the same number. Now already you should see that 4 divided by 4 equals 1. Okay. And this will not equal 1, that's less than 1. And this also will not equal 1 because this is less than 1 as well. So already we know that these two triangles are not similar because all of these answers are not going to be the same. But if we go ahead and get answers anyway, 7 over 8 is 0.875, and then 5 over 6 is 0.83. So because all three of these numbers do not equal the same thing, these two triangles are not similar. So that's your explanation. Now let's go on to this one here. Here we have a set of trapeziums, so a type of quadrilateral. We need to determine if they're similar. Same thing, okay? You need to make sure that the sides in each of these shapes align with the one they belong with. So because these are drawn in the same orientation, so they're pointing the same way or facing the same way, I could even turn my page like this and you see that the slant is on the same side, this straight line here is on the same side as this one here, these two lines are parallel, so you can go in and colour all the sides like so. Oh, that's the same colour. Now just to make sure, our longest side is 15 centimetres in this trapezium here. Oh, I'll just go back the other way since it doesn't fit. The longest side in this shape here is the 15 centimetres, and the longest side in this shape here is the 10 centimetres. So yes, they line up with one another. The next longest side in this shape is the 12 centimeters, and the next longest side in this one is 8 centimeters. So yes, they line up again. The smallest side in this shape here is 6 centimeters, and the smallest side in this one here is also 4. So we know that they all line up. Now what we need to do is find the scale factor. Okay, to see whether they are similar or not. So we'll start with green. So it's image over original. Remember, we start with an original. And end up with an image. So image of green is 8 divided by original of green, which is 12. Then we have pink. Image is 6 divided by original, which is 9. Then we'll do blue. Image is 10 divided by original, which is 15. Then we have purple, lucky last. Image is 4. Original is 6. So for these two figures to be similar, all these answers, the scale factor, must be the exact same. So let's see if we get the same answers. 8 over 12 becomes 0.67. And then we have 6 over 9 for pink, which also becomes 0.67. Then we have blue, which is 10 over 15. Now that also becomes 0.67. And to get these decimals, you can just put them in your calculator. And lastly, for purple, we have 4 over 6, which also gives us 0.67. Okay, so you can put those in your calculator to check, but because all of these answers equal 0.67, you can say that these figures are similar. Okay, and because the original is bigger than the image, you would expect the scale factor to be less than 1 because we have gone from something that's big to something that's smaller. This trapezium has become smaller, okay? It's become smaller, so the scale factor will be less than 1. Okay, now we're going to have a go at answering a question where we need to find unknown values. So in this question here, we need to find what side length x equals and what side length y equals. So first, we need to figure out which sides belong to which between the two triangles. So immediately I'll go in with my pink pen and I'm going to imagine that both of these triangles that aren't drawn to scale are turned to make sure their point is facing upwards. And if you imagine that in your head, you would see that this triangle would turn like this and that triangle would turn like this, and that the 21 centimeter side length here matches up with the 12 centimeter side length there. So DF is the same as HI. So I will do both of those in pink. And then in that case, I'd be left with the Y equaling the 14, because remember they're turned to face the same way. And then the 7 centimeters here will be the same as the X over there. And then I'm going to label my triangles with original and image. Now in this question, it's assuming that both the triangles are already similar. And then we go ahead and calculate scale factors. So remember, scale factor equals the image divided by the original length. So image length divided by original length. Okay, and we're going to find that for every single colour. So let's start with pink. Pink is image for pink. Image for pink is 21 divided by original for pink is 12. Then let's go to blue. Blue is image 14 divided by original for blue is Y. Then we finish with green. And for green, it will be image X divided by original for green is 7. Okay, so the only one that we actually have an answer for, because we have both values, is pink. And 21 divided by 12, if you put that in your calculator, you would get 1.75. Okay, so because we are assuming that both of these triangles are similar, all of these answers should equal 1.75. So the way you're going to find out what Y and X is by making sure that whatever this number is and whatever that number is, when it's divided with the 14 and the 7, it gives you this answer. Okay, so how are we going to do this? If we wanted blue to equal 1.75, which is our scale factor, okay, how would we get Y to equal 1.75? Well, this is where you need to remember your knowledge from algebra and rearranging sides to find Y. And you would know that to get Y, which we can say is down the bottom, you would need to do 14 divided by 1.75. Okay. And 14 divided by 1.75 equals 8, if you put that in your calculator. Okay. And then using your knowledge again, we need this to equal 1.75, which is the scale factor. Using your knowledge of rearranging sides in algebra, you would know that you'd get X by doing this as a multiplication. Which equals 12.25. Okay, so basically whenever you have an unknown down the bottom of a fraction or division, however you want to view this, and you have an answer, it's always whatever's on top of it divided by what's on this side. And then if your unknown is at the top of the fraction, so again, however you want to view it, whether you want to see this as a numerator, you just multiply whatever's down the bottom or the denominator by whatever the answer is. So then you can go ahead and say that X equals 12.25 0.25 centimeters, and y equals 8 centimeters. And then a lucky last, we're going to finish with 2 kites. So you're finding the unknown values, and this time we have a lot of unknown values to find. Now you need to line up which side belongs to which. Now the final question we're going to go through is finding unknown values between 2 similar figures that are in the shapes of a kite. So we're going to do what we've been doing the whole entire time, and we are going to underline the sides that match up with one another. Now, if we did that, we would find that the 18, the 11.5, the 13, and the G must all somehow match up with one another. So the 13 centimeters, which I'll go in green, that is one of these equal lengthed side lengths up here, will match up with this one over here. Okay, now these values are actually the same. So if this is 13, that's 13. If this is 11.5, that's also 11.5, because these are the same, as you can tell by the dashes on these lines. Okay, so we'll do those in green. And then in pink, the G is left over with 18. Okay, and whatever G is will be the same over there. 18 is the same over here too because of the double dashed lines. Okay, so scale factor. What's our formula? Image, length over original length. Label which is which. Original's first, image is what it becomes, image is left, original is left, image is right. Okay, so let's do our working out. Start with green. Image for green is 13 over original green, 11.5. And then we have pink. And for pink, we have image G over original 18. Okay, so now we have to go ahead and find out what 13 divided by 11.5 is, and that equals 1.13. So because these kites are similar, the scale factors must equal the same thing. So whatever this is, it must equal 1.13. Now, remember, when your unknown is at the top, you must multiply whatever's down the bottom by the answer. So to find out what G is, you would do 1.13 times by 18. Which, if you round to 1 decimal place, you get 20.3. Okay, so G equals 20.3 centimeters. Okay, and if you put 20.3 and substitute it in for the G and did divide by 18, you would get 1.13. Right, so if your unknown's at the top, you multiply the bottom to the answer. Now, what about angles that are on the inside? Just because the image is larger than the original, and you should know that by looking at the scale factor, when the scale factor is bigger than 1, the image is larger than the original. It's grown bigger, so the scale factor is greater than 1, so that makes sense. Even though that's happened, internal angles still remain the same size. Now, to find out what A, B, C, D, E, and F equal, you must go back and use your knowledge of angles inside of a kite. Now, if you did, you would know that these angles equal the exact same number, and these do not. So you would say F equals 125 degrees. And then because a kite is a quadrilateral, you would do 100, to find E, you would do 125 plus 50 plus 125. Whatever that equals, so I guess I'll do a plus there as well. So E plus 125, 50, and 125 must equal 360 degrees all up. Okay, now you need to find out what 125 plus 50 plus 125 equals. That's 300. So E plus 300 equals 360. So E must equal 60. And you know the point to this kite here. Now, whatever these numbers are must be the same in this one. So that means that A is also 60. Okay. C is also 50. And B and D are both 125 degrees.